How can I use X bar to make conclusions about mu? In the same way, we can use R, the correlation of the sample, to estimate, and this is a new letter, this is the Greek letter R, rho, and rho is the correlation of the population, okay? So, just like, so yeah, the big idea behind the difference between R and rho is no different than the difference between P hat and P, than the difference between X bar and mu, okay? It's just we use the correlation of a sample to make conclusions about the correlation of a population. So, our hypotheses for a correlation test are going to be about rho. So, you have essentially 3 different options for your hypotheses. That shouldn't surprise you. Now, when we're looking at this, we're trying to decide, is there a relationship of some kind? Okay, so when we're writing our hypothesis, our null hypothesis or our alternative hypothesis is going to be related to the type of relationship we're trying to find. So if I have a scatter plot that looks like this, and all I want to know is there a linear relationship? Not saying positive or negative, just saying linear. Well, what we want to ask ourselves is, what would it mean for there to actually be a relationship? And the easiest way to think about that is, what is the value of R when there's no relationship between my variables? Zero. So if there is a relationship, that would mean rho is not equal to 0. And if that is my null hypothesis, what would my alternative be? Rho is equal to 0. All right. What if I said, is there a positive? What would that say about rho? If the relationship is positive, no. Because, first of all, rho will never equal 1, because you're going to have at least a little bit of chance variability, okay? So it's going to be that rho is greater than 0. Leaving my alternative hypothesis or my null hypothesis to be less than or equal to 0. And likewise, if I say, is there a negative relationship? Then my hypotheses would be my alternative would be that rho is less than 0. And my null then would be greater than or equal to 0. We feeling okay so far? Okay. Now, the 2 examples I'm going to use today are the traditional method rather than the p-value method. The reason I'm choosing to do traditional method today is we've done a lot with p-value method, right? But you're still on the final going to be expected to use the traditional method. So I want to go back and review what that looks like, okay? Now, all right. Now, when we're talking about, so we're going to calculate a t-statistic. Here's our formula for the t-statistic. No, you do not have to have this t-statistic memorized. I will give you this, and frankly, there's a calculator shortcut anyway. Okay? So getting the t-statistic, no problem. Okay, I want to remind you the difference between the critical value and the test statistic, because it came up yesterday when I taught second period. Okay, the critical value is the theoretical value calculated from alpha. whereas the test statistic is the observed calculated from your sample. Everybody good? All right, and when we make that critical value, essentially what we create a rejection region. So we make our conclusion based on whether our test statistic is in the rejection region or not. Is this feeling familiar? All right, so let's go ahead and look at it like we did. This example, if you do not already have this data in your L1 and your L2, can you please put it in your L1 and your L2? Everybody got them in or close? All right, so the first thing I want us to do is go to the question and decide what do I need my alternative hypothesis to be based on the wording of the question. What do you think? If there is a significant relationship, we're not designating positive or negative. So my alternative hypothesis, I don't know why I wrote the H again, completely ignore that, is rho not equal to 0. Leaving my null hypothesis to be rho equals 0. Okay, now that I have my alternative hypothesis, I don't know when I stopped recording. I hope it's not. If I did, it was accident. Okay, you guys. So this is just copied from the previous page. A reminder, it is on your formula sheet. You would not be expected to memorize this formula. All right, so, and did we find the line and stuff for this data on Monday? Okay. All right, so we need to find R. So a reminder of how, one of the ways we can do it. All right, ignore this right now. Okay, I can hit stat, arrow over to, oh, I should double check, but I'm pretty sure I have these in my L1 and L2. Those look, are those the right numbers? Yeah, they look right to me too. Okay, stat, arrow over to calc, and do option number 8, where it says if we do this all the way through, I can see here that R is equal to 0.9.
Put anything in frequency list or store.
No.
Right.
0.933. Nope.
What goes in store reg?
Nothing.
Oh, so just L1, L2.
Just L1 and L2. Or whichever list you have your data in. Okay, everybody good? Okay, so to calculate our t statistic, we would do 0.933 divided by the square root of 1 minus 0.933 squared over 7. So we already said n minus 2 was 7.
You said you use option 8?
Yeah. Did you not get the R on it?
No, I guess we had A and B.
Hit mode. And then scroll down to the bottom where it says stat diagnostics.
Turn it on.
And turn the stat diagnostics on, yeah. Oh, you guys, I was about to make a huge mistake. There we go. So our T statistic is 6.859. Okay, you guys. Where is 6.859? Like it's like here. Everybody with me?
Yeah.
It would be way over here. Probably a little bit further, but I'm running out of room. You know what I'm saying? Okay. So is it in the rejection region? So what decision are we going to make? Reject the null. Sweet. Okay. If I reject the null, what does that mean? We have or do not have enough evidence. You have enough because we only have one hypothesis left.
Yeah,
Okay.
I don't know why I said that.
We have enough evidence to say there is a significant linear relationship or linear correlation. If you said relationship, I wouldn't care at all. Between the year and price of a Honda Civic.
Did you say for the t-test statistic that we would have a shortcut or we would?
Yeah, I'm going to show it to you right now. Okay. You guys. If you go into your stat, and where have all the calculator shortcuts for tests been? Stat, arrow over to tests. The very close to the bottom, you see a lin reg t-test. Go ahead and hit it. Make everything, match. You're going to leave that reg equation blank. Everybody good? It's important that you know, like, your X list, the in this case, year is X and price is Y. Okay, it's important that you have those matched up appropriately. Okay? I hit calc. All right, and as you can see, there's our test statistic. There is a p-value. Is anybody shocked to see that this p-value is so low? Where was our test statistic? That p-value is like the area out here. Like it should be really low. Is everybody okay? Now, It also gives you this other information, like if I asked you to write the equation of the line, it gives you, well, one, the line is going to be written a plus bx, and then it gives you the a and the b. You just need to fill it into that form. So I can look at my calculator here, and let's see if I can't do this a little bit easier for myself, and say my equation is y hat equals -1867280.952 plus 935.714x. In statistics, we tend to write the y-intercept first, and then the slope term second.
Okay. I was just confused that we were writing that.
Well, it's asking for this is how you would find the equation of the line.
When's our test?
Tuesday. Wednesday for you guys.
It's just the last.
This is your last day of doing notes.
That's crazy. That's the last normal test before the exam, or that?
For the final, yeah. And then the final will be essentially the following Wednesday.
I'm gonna have an AP test today.
I tried to plan it so nobody had an AP test. I don't think. If there is, we'll talk. There's no reason why you couldn't take it.
It might be Tuesday, not Wednesday. Might be.
Which one do you have? Tuesday is stats.
So okay, so it's,
And I don't know the
I
morning.
know Gov is Monday that week.
We'll look it up when I finish the notes. And I thought I planned them so that those are those days that we aren't offering any AP testing. Like I worked kind of hard at trying to figure it out. You guys do need to plan into going into lunch for that day. Is everybody with me? Because it's a 2-hour test and they're not letting me give it over 2 different days. I was specifically, for this course only, they're not letting me do that. That Wednesday the 8th.
So bad for the period that has to come in at 7:30. That sucks.
I just don't know what else to do.
No, I mean that makes sense. Actually, coming in at 7:30 and staying for lunch are probably equal.
Depends on if you're a morning person or not. Okay. For those kids, if they have 4th period study hall, and same for you guys, if you had 1st period study hall and want to come in a half hour early, I would be okay with that. If you don't want to go into lunch, that's up to you guys. Just communicate with me. Like, I want to be flexible, but I have to have each of you take it in a 2-hour sitting. And it needs to be done by the end of that week because grades are due May 10th. And then we're done. Kind of
So
crazy.
Just 5 days of like nothing if grades are due. Oh, never mind. This is C-State.
Yeah. And then, so you'll basically have a week in between this test and the final. I'm almost done with my key to the final. My first step is going to be compare it to the tests I've written and see like what's different. We'll talk about, there's like some different sets of expectations that one I also want to clarify with him before I do that. And then what we'll do is go through like my test. I'll say, okay, in the what they want on the final, this is how you might answer this question. And then I'll look at the review and say which problems outside of my tests should you be reviewing. I was planning on each day of those weeks either letting you guys either correct your tests, not for points, but rather to review. So far, I haven't seen anything that isn't on any of my tests. But I haven't done the last one. I've got 2 pages left of the final. Okay. All right, can you guys go ahead and put these in your calculator?
I'm not good for AP test.
You are good?
Yeah. I just wanted
Yeah.
to on one on Monday.
I think I figured it out that I know on Tuesday there's no AP test being given. Because the tests that are scheduled from the College Board are not ones we offer.
It's confusing with the Tuesday following too.
So one on top always L1. Does it not matter?
Technically, like your independent versus dependent variable. So it's like in this particular case, we're trying to decide does the number of homes influence the sale price of the house, right? So the sale price would depend on how many homes. That one should be your X list. The independent variable should be your X list, and your calculator is going to default to X list is L1 and Y list is L2 unless you tell it something different. Just as an FYI, when I do this, because I wanted to save both sets of data from these notes, when I did this in my calculator, I'm going to do the test on L3 and L4. But the reason I'm doing it on L3 and L4 is I didn't want to delete out the other stuff from when I was teaching you guys. But you guys have it in L1 and L2.
I have a question about just while I'm doing this picture.
Mm-hmm.
So on this picture that you drew me over here,
Mhm.
that's for the confidence levels, right?
Mhm. On Monday, that's going to be a significant piece of what we review on Monday. I'm assuming when you guys come in on Monday to review for the test on Wednesday, you guys were going to spend the bulk of that on Unit 10 or Unit 9.
Yeah.
The t-test, the 2 sample tests. It's just an assumption.
Yeah.
By far, that's the homework that has gone the worst. Like, just like in Unit 10, I made them yesterday do the Unit 11 homework instead of passing out the lab, and it went way better. That's definitely going to be a change I make for following years, is that the homework needs to be due sooner and the labs due later. All right, you guys. How is this one a little bit different?
Negative correlation.
Because I want to know, is there a negative linear correlation? So my alternative is going to be rho is less than 0. Okay? Which makes null rho is greater than or equal to 0. And as I calculate that critical value, I'm only shading the exact wrong side. Pretend I shaded the left side. Well, that one was a little bit different, right? All right. And what are my degrees of freedom here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 minus 2 is 8 degrees of freedom. What are we getting?
Negative 2.896.
Okay. Now, as we think through this, guys, would you guys expect a negative relationship here between these two variables? Let's kind of think through logically. Would we expect that if there's more homes on the market, the sale price would go down? Why?
Because there's
More competition, yeah. So when there's not a lot of homes, you can charge, if someone needs to move, you can charge them a little bit more, yeah? Okay, and it is worth noting that in reality we would probably look at a scatter plot of our data and make sure that that scatter plot is showing a negative. You guys, I don't think that's the graph you want to see, is it? It's not. Yeah. Let's go ahead and turn these off. And then do some zoom 9 action. And I see a negative relationship here, don't you guys? That looks negative. Cool. All right. Can you guys please calculate the test statistic for me?
Is there a shortcut so we don't use that for me?
Does somebody else want to take this?
She just said it.
No, but to find the T, I don't think there's line right to find the T.
Look,
Oh, I must be wrong.
it gives you both.
Oh, man. I just completely skipped over it.
You guys, what's our T statistic?
-4.9.
And is that in our rejection region? Yeah, because -4 would be roughly here, yeah? Give or take? Okay, now, if I ask you to use the traditional method and justify your reasoning, which you want to justify how you're making your conclusion, I would expect to see not just what the T statistic is, but also what you're comparing it to make that value. Likewise, what's the p-value on this?
Very small.
Very small, yeah? I would expect you to say that that p-value is less than 0.01 if you're using the p-value method. So no matter what, you're comparing either your test statistic to your critical value, or you're comparing your p-value to alpha. Either way, I need to see that comparison. Everybody good? All right, and okay, so let's see. That makes me want to reject. Woohoo! Okay. So my conclusion will be we have enough evidence to conclude what?
Negative, linear correlation between homes on the market and average sale prices.
And the equation of the line? What are you guys getting?
74.625.75.
So y hat equals Okay. And as we think through this, guys, so the linear relationship suggests that more homes on the market equals less selling price, yes? That's what we basically just figured out. The more homes there are in the market, the lower the selling price on average is. And at what rate?
Negative point, or not point, 1,096.4.
The slope. The slope describes what's going on. So, like, if I were to be like, oh, I would read that and say that for every one extra home on the market, the average selling price is going down by approximately $1,100. Everybody good? Okay. Now, for this next piece, before we get going, I need to put this into this lovely little program on my laptop. Before I want to describe what's going on, I want you guys to see it. So I need to put the data in. Oh, that's not helpful. That is. This part's going to be annoying. All right. You guys can see this, yeah? So here's our... Okay. Now, what I'm going to do here first is plot a line that is pretty darn close to the mean of the y-coordinates, which... Okay, so this line right now, okay, this line right now is the mean of all the y-coordinates. All right, and so as we look at this line, we can see that this is not a good estimator of y. Is everybody good? Comparatively. Now, if I had only given you this column, right? If I only gave you the average prices, the mean would be our best estimator of what's going on, because that's all we would have. Cool? Okay. So I have this line, and what I'm going to do is show you something called a residual square. You don't need to, and all I need you to get about these residual squares right now is that these squares are essentially the that distance. That's what determines the size of the square, is that distance these values are from the mean. Is everybody with me? Okay. Now, I got rid of my label, and now I feel like I'm going to want my label. Nope. Okay, so here's what's going to happen. So right now, these squares don't care about the x number at all because they're only based on the mean of those y's. Is everybody with me? Now, very slowly, I'm going to move this line. The squares are going to stay up there, okay? And I'm going to move this line so that the line matches the scatter plot. Is everybody with me? Okay? And when I do that, what's going to happen to those squares?
Smaller.
They're going to get smaller. Is everybody with me? All right. And so right now, the squares represent all of the variation in y. And in fact, those squares are practically, not quite, but practically, a representation of the standard deviation of the y's. Is everybody good? Because what's standard deviation? Average distance from the mean. So those squares are made out of the distances from the mean. Everybody good with this idea? Okay. So I have all of this variation in y, and when I move the line so that it starts to match, what I end up doing is explaining I'm explaining the relationship between x and y. The line is the explanation of what's actually going on between these two variables. That's the whole point of the line. Is it maps out this like understanding of what that relationship could be. Okay. Are there still squares left? Yeah? Okay. So those squares represent the unexplained variation that it's still not a perfect line, it's still not a perfect relationship, nor would we expect something to. So the picture of this is that I want you guys to kind of get out of this is that we have the explained variation is what kind of went away from the squares. And then this is the unexplained variation. Okay. So if we take that value r, and if you notice when we ran these in the calculator, we didn't just get r. Our calculator also gave us r squared. Everybody with me? R squared is a very specific term, calculation, that has a very specific interpretation.
I did some of those in 1 and 2 recently, right? With some of the graphs.
Yeah, we related them back to r, but because like we used r squared to understand, like we said, if r squared was close to 1, then it was a strong versus not strong relationship, right? And r squared is going to be close to 1 when r is close to 1. So the reasoning we used was actually about r, not r squared. It just so happened that it worked that way. The way we interpret r squared is that it's like the percent of the time that it's the percent of the time of the variation in y that can be explained by y's relationship with x. So going back to your calculators, guys, what was the r squared for this particular set?
0.749.
Perfect. Okay. If I had to interpret that value, I would interpret that as 74.9% of the variability in sale price of a home. That's my y context, yeah? Can be explained by the number of homes on the market. All right. Now, feel free to take a break because that was a lot all at once. And then, so take that break, but then also start working on the Unit 11 homework online.